Welcome to the deep dive. Today, we're diving into the world of Git.
Git?
It's a version control system
All right.
that's become like the backbone for modern software development.
Yeah,
But guess what?
right.
It's not just for hardcore coders anymore.
That's right. Git's branching out, pun intended.
Oh, nice.
It's a powerful tool for anyone working with files that change over time,
Yeah.
whether it's code writing, design, you name it.
Exactly. Think of it as track changes on steroids.
Oh.
You can rewind to any point in your project's history,
Wow.
see who changed what,
Right.
and even create alternate timelines for experimenting without fear of messing up your main project.
It's like having a time machine for your files.
It is a time machine.
Yeah.
Speaking of time machines,
I
we're
bet.
diving deep into the Pro Git book itself.
The Pro Git book.
It's like the ultimate guide
Yeah.
to understanding not just the how, but the why of Git.
And believe me, the why is just as fascinating as the how.
I believe you.
We'll uncover the story behind Git's creation,
Okay.
its unique philosophy, and how it revolutionized collaboration in the open source world.
You'll learn things like Git doesn't actually store changes the way you might think.
Huh.
It's more like a series of snapshots.
Interesting.
Plus, it almost never deletes data.
What?
Once it's committed, it's really hard to lose,
Wow.
which can be a lifesaver
Yeah,
or a bit scary depending on what you commit.
that's true.
We'll even explore how Git's meteoric rise went hand in hand with the success of a little company called GitHub.
Oh, yeah.
You might have heard of them.
Just a little.
So buckle up. By the end of this deep dive, you'll not only grasp the basics of Git, but you'll see why it's become the go-to tool for developers and creative folks alike, ready to go from Git newbie to Git ninja.
Let's get started.
First stop, Git's origin story. Imagine the pre-Git world. You've got a team working on a software project, everyone's making changes, and it's all centralized on one single server.
Okay.
What's the biggest problem with that picture?
The single point of failure? If that server goes down, everyone's stuck. Plus, the risk of data loss is huge. One corruption, and your entire project could be toast.
Not a good situation.
Not at all.
Enter Linus Torvalds,
Linus Torvalds.
the creator of Linux.
Right.
He was facing this exact problem with the Linux kernel development.
Yeah.
And he wasn't happy with the existing version control systems.
He wanted something distributed,
So,
where every developer had a full copy of the project history. That way, even if one repository went down, the project wouldn't be lost.
Smart.
Brilliant, right?
Totally. And that's exactly what Git is.
Yes.
It's a distributed version control system.
All right.
It's more like a mini file system than just a way to track changes.
I like that, a mini file system.
Everyone has the complete timeline of the project,
Right.
making it incredibly resilient and collaborative.
It's like the difference between having a single master copy of a document and everyone having their own editable version.
Yeah.
With Git, you can work offline experiment freely and then easily merge your changes back into the main project.
Okay, so Git sounds awesome in theory.
It does.
But how do we actually use this thing?
Right.
Let's walk through some basic commands using examples from the Pro Git book.
What?
Imagine you found a cool open source project online
Right.
and you want to work with it. What's the first step?
You get clone the repository.
Git clone.
It's not just downloading the files. It's
Yeah.
getting a complete copy of the entire project history. Every change, every commit, everything.
So you're not just getting the finished product, you're getting the behind the scenes footage of how it was made.
Exactly.
Now let's say you've made some changes to the project.
Okay.
How do you tell Git, hey, I want you to track this new stuff?
This is where git add and git commit come in.
Git add and git commit.
You got it. Git add is like saying, okay, take a look at these files. I'm ready to include them in my next snapshot. You're staging those changes.
So it's like choosing the best photos from a photo shoot before you share them with the world.
Perfect analogy.
Then git commit is where you take that snapshot,
Yes.
capturing the state of your project at that specific point in time.
Uh-huh.
Each commit is like a milestone in your project's journey.
I like that each commit is a milestone.
Each commit also requires a message, right? This is where you explain what you changed and why it's super helpful for understanding the evolution of the project.
Absolutely. Think of commit messages as little notes to your future self and your collaborators explaining what each change was all about.
Now, before we go any further, let's talk about this magical file called .gitignore.
Gitignore.
It's like a bouncer at a club deciding who gets in and who stays out of your Git repository.
Yeah.
What's the purpose of this file?
It's for excluding files that you don't want to track with Git.
Okay.
Things like temporary files, log files, or files generated during the build process.
Yeah,
It helps keep your repository clean and focused on the essential source code.
I see.
Plus, it prevents accidental commits of sensitive information, which is important for security.
And thankfully, GitHub, like the helpful friend they are, provides a ton of Gitignore templates for different programming languages and project types, right?
Absolutely.
Yeah.
They've got you covered no matter what you're working on. It's a great resource to get started, but wait, there's more.
More.
Git has even more tricks up its sleeve, even at the beginner level.
Okay, spill the beans.
Right.
What other commands should every Git newbie know?
Well, there's git diff.
Git did.
This command lets you see the differences between your changes and the previous version of a file. It's like a detective highlighting what you've added or removed.
So it's like a before and after photo for your code?
Yes.
What about Git log? What does that do?
Git log shows you the history of commits, like a timeline of your project's evolution. You can see who made each commit when and the commit message they wrote. It's like a history book for your project.
And finally, what about Git restore? That sounds like a lifesaver.
It is Git restore, allows you to undo changes either in your working directory or in the staging area. It's like a time machine, letting you go back to a previous state of your project.
Okay, so we've got our basic Git commands down.
We do.
We can clone a repository, make changes, stage them, commit them, and even undo things if needed.
Yep.
But now let's talk about Git's superpower.
Okay.
Branching and merging.
Branching and merging.
This is where Git really starts to shine, allowing you to create alternate timelines for your project without affecting the main one. Think parallel universes for your code.
It's a game changer for collaboration and experimentation.
Yeah.
You can create a branch for a new feature, test it out, make sure it works, and then merge it back into the main branch when you're ready.
So walk us through how branching works in Git.
Sure.
How do we create a branch, switch between branches, and merge them back together?
To create a new branch, you simply use git branch, and then the branch name to switch to that branch, you use git checkout, and then the branch name.
And what about merging branches back together?
To merge a branch into your current branch, you use git merge, and then the branch name git will try its best to automatically combine the changes from both branches.
What if there are conflicts, like two people changing the same line of code in different ways?
That's when Git needs your help.
Uh-oh.
You'll have to manually resolve the conflict by choosing which changes to keep and which to discard.
So it's like being a code referee, making sure everyone plays by the rules.
Exactly. And here's a pro tip. Before switching branches, make sure you have a clean working state that means either committing or stashing your changes.
Stashing? What's that?
Stashing is like putting your changes aside temporarily without committing them. It's super useful when you need to switch branches quickly, but don't want to commit half-finished work.
So it's like the pause button on our coding session.
You got it.
Okay, we've covered a lot of ground here. We've learned about Git's origins, its distributed nature, basic commands, and even branching and merging, but this is just the tip of the iceberg.
There's so much more to explore. We'll dive into collaborative workflows, advanced Git techniques, and even the impact Git has had on the software development world as a whole.
Stay tuned for part 2, where we'll take your Git knowledge to the next level. Welcome back to the Deep Dive. We're knee-deep in the world of Git, and in this part we're going beyond the basics and exploring how Git makes teamwork a dream.
Because let's face it, coding in isolation is like playing a solo in an empty concert hall. The real magic happens when you collaborate, share ideas, and build something amazing together.
Exactly, and Git is the perfect conductor for that collaborative orchestra. So picture this. You've got a team of developers, each with their local Git repositories, all working on the same project. How do they effectively share their changes and keep everything in sync?
That's where remote repositories come in, like a central hub for your project's code. Think of it as the virtual concert hall where everyone brings their instruments and plays in harmony.
So it's like a shared online space where everyone's code can live and breathe together?
Exactly. Developers can push their changes to this central repository and pull in changes from others, ensuring everyone's working with the latest and greatest version of the code.
Sounds straightforward enough, but wait, what about conflicts? If multiple developers change the same file, wouldn't that lead to chaos?
That's where Git's merging capabilities come into play. Remember, Git is incredibly good at automatically merging changes, even when multiple people have modified the same parts of a file. It's like a musical arranger blending different melodies together into a harmonious composition.
Wow, that's impressive. But I imagine there are times when Git throws up its hands and says, I need a human conductor to sort this out.
That's true. Merge conflicts can occur, especially when changes overlap in complex ways. In those cases, developers need to manually resolve the conflicts by comparing the different versions and making decisions about what to keep. It's like a conductor mediating a disagreement between two musicians, ensuring everyone's playing the right notes.
So it's a bit like being a code detective piecing together the puzzle of conflicting changes.
Precisely. And once the conflicts are resolved, the merged changes are committed to the repository, creating a unified history that reflects everyone's contributions.
Yeah.
It's like the final performance, a beautiful symphony created by the collective effort of all the musicians.
I'm starting to see how Git makes collaborative coding so much smoother than the old ways of doing things like emailing patches back and forth.
Oh, absolutely. Email-based workflows were a nightmare, especially for large projects.
Yeah.
It was like trying to conduct an orchestra through handwritten letters. Git simplifies collaboration, provides a clear and traceable history of every change, and keeps everyone on the same page.
Speaking of keeping everyone on the same page, let's talk about branching strategies. I hear that well-planned branching can be a lifesaver for teams, especially when working on large features or complex projects.
Branching strategies are essential for organizing development workflows. They're like having different sections in the orchestra, each working on their part of the symphony. One common strategy is to have a main branch, often called master, which represents the stable and production-ready version of the code.
So master is like the main stage where only polished performances take place.
Exactly. Then developers create separate branches for new features, bug fixes, or experimental work. These branches act as isolated sandboxes, allowing developers to work independently without disrupting the stability of the main branch. It's like having multiple rehearsal spaces where different sections can practice their parts before joining the full orchestra.
It's like having multiple rehearsal spaces where different acts can prepare their routines before the big show.
Precisely when a feature or fix is complete and tested, it's merged back into the main branch, ensuring that everything is integrated and ready for release.
Right.
It's like all the sections coming together for the final performance, each playing their part in perfect harmony.
And this brings us to the concept of pull requests, which I hear are a cornerstone of modern collaborative coding. They're like a way for developers to showcase their work and get feedback before it goes live on the main stage.
Pull requests are a fantastic mechanism for proposing changes and initiating code reviews. It's like submitting your musical arrangement for review by the conductor and other musicians before it's included in the final performance.
So it's like saying, hey, team, check out my awesome code and let me know what you think.
Exactly. The pull request process allows for thorough code reviews, discussions, and collaboration before changes are integrated into the main code base. It helps ensure code quality and catch potential issues early on. It's like having a dress rehearsal where everyone can provide feedback and make adjustments before the big show.
It's like having a panel of judges critique your performance before you go live on stage. This sounds incredibly valuable for teams.
It is pull requests to become a standard practice for open source projects, and many companies they foster collaboration, transparency, and high-quality code. It's like having a culture of continuous improvement where everyone's working together to create the best possible performance.
Okay, so we've covered branching, merging, and pull requests. But what about those times when we need to step back in time to revisit or even revise our project's history? Is that even possible with Git?
It most certainly is. Git offers powerful tools for navigating and manipulating your project's history. It's like having access to the archives, where you can review past performances, identify areas for improvement, and even make adjustments to the score. We've already touched on rebasing, which allows you to rewrite history, but let's dive into a few more time-traveling techniques.
Time travel for code. This is getting exciting.
One essential command for understanding your project's past is git log. It's like a historical record that shows you the sequence of commits, their authors, timestamps, and commit messages. It's like reading the program notes, where you can see the evolution of the performance over time.
So GitLog, it's like a time machine that lets us browse through the annals of our code base.
You got it. And if you want to see the specific changes introduced in each commit, you can use the -p flag with GitLog. It'll show you the diffs, highlighting what was added or removed in each commit. It's like comparing the original score to the revised version, seeing exactly what's changed.
Ah, so it's like peering through the looking glass of code evolution.
Precisely. Now let's say you've discovered a bug in your current version, but you're not sure when it was introduced. How would you track down the culprit commit?
Sounds like a case for some serious code sleuthing.
This is where Git bisect comes to the rescue. It's a powerful debugging tool that helps you pinpoint the commit that introduced a specific issue. It worked by performing a binary search through your commit history. It's like a detective narrowing down the list of suspects, eliminating possibilities one by one until they find the culprit.
A binary search for bugs that sounds efficient.
It is. You start by telling Git a good commit, where you know the code worked correctly, and a bad commit, where the bug is present. Git then checks out a commit halfway between the two, and you test to see if the bug is there.
So it's like narrowing down the suspects in a crime investigation.
Exactly. You keep telling Git whether the commit you're testing is good or bad, and Git keeps having the search space until it finds the culprit commit. It's like a game of hot or cold guiding you toward the source of the problem.
Wow, it's like Git is Sherlock Holmes for our code. But what if we realize we've made a mistake in a commit, like typo in the commit message, or accidentally including the wrong file? Can we fix those blunders?
Absolutely. Git gives us the power to amend commits, even those that are further back in history. It's like having an eraser for our coding mistakes, even those made in the distant past.
So it's like having an eraser for our coding mistakes, even those made in the distant past.
Exactly. For recent commits, you can use git commit amend. This allows you to modify the last commit, changing the commit message, adding or removing files, or even combining stage changes with the previous commit. It's like making a slight adjustment to the score, correcting a minor error before the next performance.
So it's like giving our last commit a little makeover.
Precisely. But what if you need to change a commit that's buried deeper in the commit history?
That sounds trickier.
It does require a bit more finesse for such cases. You can use interactive rebasing with Git rebase. This powerful tool allows you to pick and choose which commits to modify, reorder them, or even squash them together. It's like editing the score, removing unnecessary notes, combining measures, and refining the composition for a more polished performance.
Wow, it's like having full editorial control over the timeline of our code, but with great power comes great responsibility, right?
Indeed. It's crucial to use interactive rebasing carefully, especially when working collaboratively. Rewriting history can cause headaches for others if they've based their work on the original commits. It's like changing the score without telling the musicians, which could lead to a lot of confusion and disharmony.
Okay, so always proceed with caution and make sure everyone's on board before messing with shared history. But what about those times when we need to undo changes completely, like reverting to a previous version of a file or even rolling back the entire project to a specific commit? Can Git handle that?
Git has us covered there too. It provides several ways to revert changes both at the file level and the commit level. It's like having a backup of the score, allowing you to restore a previous version if something goes wrong.
So it's like having a safety net for our coding adventures.
Exactly. To undo changes to a specific file, you can use git checkout and the file name. This will revert the file in your working directory back to the version that's currently committed. It's like restoring a specific page of the score to its previous state.
Yeah, so it's like restoring a file from a backup. What about rolling back the entire project to a previous commit?
For that, you'd use git, revert this command, creates a new commit that undoes the changes introduced by a specific commit. It's like creating a new version of the score that reverts to a previous arrangement.
So it's like hitting the undo button on a series of actions, except it creates a new record of that undoing. Why not just delete the bad commit?
Remember, Git is all about preserving history, even the mistakes. Reverting a commit maintains a complete and traceable record of everything that's happened in your project, which can be valuable for debugging and understanding the evolution of your code. It's like keeping all the drafts and revisions of the score, providing a complete history of the creative process.
That makes sense. Git's commitment to preserving history can be a real lifesaver in some situations. So we've covered a lot of ground here, from the basics of Git to more advanced techniques for collaboration branching and history manipulation. But before we wrap things up, I want to touch on something that's become increasingly important in today's world: security. How does Git handle the security of our precious code?
Security is paramount, especially when dealing with collaborative projects or sensitive code bases. It's like protecting the score from theft or unauthorized modifications. Git offers several mechanisms for enhancing security and protecting your code from unauthorized access or malicious changes.
Okay, let's dive into the security fortress of Git. What are some of the key security features?
One of the most fundamental security measures is authentication. When working with remote repositories, you typically need to authenticate using credentials, like a username and password, or an SSH key. It's like having a lock on the door to the concert hall, only allowing authorized personnel to enter.
So it's like having a password-protected vault for our code.
Precisely, this prevents unauthorized users from pushing changes to the repository or accessing sensitive information. It's like preventing someone from sneaking in and tampering with the score or stealing the instruments.
That's reassuring, but what about verifying the integrity of our code? How do we know that the code we're pulling from a remote repository hasn't been tampered with?
That's a great question. Git uses cryptographic hash functions to ensure the integrity of every commit. Each commit has a unique SHA-1 hash, which is a digital fingerprint of its contents. It's like a seal of authenticity on the score, guaranteeing that it's the original and hasn't been altered.
So it's like a tamper-proof seal for our code.
Exactly. If even a single bit changes in a commit, its SHA-1 hash will change, alerting you to potential tampering. It's like noticing that the seal has been broken, indicating that someone might have tampered with the score.
That's impressive, but what about ensuring the authenticity of commits? How do we know that a commit actually came from the person or entity it claims to have come from?
That's where digital signatures come into play. Git allows you to sign commits and tags using GPG, which is a widely used encryption and signing standard. It's like the composer signing the score, verifying its authenticity and authorship.
Ah, so it's like having a digital notary for our code.
Precisely. A GPG signature verifies the author of a commit or tag, ensuring that it hasn't been forged or altered. It's like having a certificate of authenticity, guaranteeing that the score is indeed the work of the claimed composer.
So Git's got authentication, integrity checks, and digital signatures. That's a pretty solid security arsenal.
It is. And these features work together to protect your code base from unauthorized access, tampering, and malicious modifications. It's like having a security system in place to protect the concert hall, the instruments, and the score, ensuring a safe and secure environment for the performance.
That's great to hear, but I'm curious, what about hosting Git repositories? We've mentioned GitHub a few times, but what other options are out there and how do they compare in terms of security and features?
That's an excellent question. Choosing a Git hosting provider is a crucial decision, as it impacts not only the security of your code, but also collaboration features, access control, and overall workflow. Let's explore some of the most popular options.
Let's embark on a tour of the Git hosting landscape.
First up, we have GitHub, the undisputed behemoth of Git hosting, especially for open source projects. It's a social coding platform that has revolutionized the way developers collaborate and share code. It's like the Carnegie Hall of Git hosting, where the best and brightest come to showcase their work.
GitHub's become synonymous with open source. What makes it so popular?
GitHub offers a wealth of features, including free public repositories, powerful collaboration tools like pull requests and issue tracking, and a massive community of developers. It's like a vibrant cultural hub where musicians, composers, and music enthusiasts gather to share their passion and collaborate on exciting projects.
It's like a giant virtual hackathon constantly buzzing with activity.
You could say that GitHub also places a strong emphasis on security, with features like two-factor authentication, signed commits, and regular security audits. It's like having a top-notch security system to protect the concert hall and ensure the safety of everyone inside.
Welcome back to the deep dive. We've covered a lot of ground in our exploration of Git, from its humble beginnings to its powerful features for collaboration, branching history manipulation, and even security.
It's been quite a journey. But we're not done yet. We've talked about the how and the why of Git, but now it's time to zoom out and see the bigger picture.
Exactly. We've touched on GitHub as a popular hosting platform, but what are some of the other options out there and how do they compare in terms of features and security?
Well, besides GitHub, we have GitLab and Bitbucket. GitLab is known for its robust CI/CD capabilities, continuous integration, continuous deployment, making it a favorite among DevOps teams.
So it's like having a built-in stage manager who can automate the process of getting your code from rehearsal to the final performance.
Precisely. GitLab also offers both cloud-based and self-hosted solutions, giving you more flexibility in terms of deployment. And of course, they prioritize security, just like GitHub.
What about Bitbucket? What's their claim to fame?
Bitbucket is a strong contender, particularly for teams already using Atlassian products like Jira and Trello. It integrates seamlessly with those tools, providing a unified platform for project management and software development.
So it's like having a single backstage area where everyone involved in the production can communicate and coordinate effortlessly.
That's a great analogy. And like the others, Bitbucket also takes security seriously with features like IP whitelisting, two-factor authentication, and SOC2 compliance.
Okay, so we've got GitHub, GitLab, and Bitbucket, all excellent options for hosting your Git repositories. But what if you need even more control over your data and infrastructure?
That's where self-hosting comes in. It's
Yeah.
like building your own concert hall, having complete control over the stage, the lighting, the seating, everything.
So you're not relying on a third-party venue. You're creating your own space. What are some options for self-hosting a Git server?
Git itself comes with a built-in server called Git daemon, which is a lightweight option for serving Git repositories.
So it's like having a bare-bones stage perfect for small, intimate performances.
Exactly. But if you need more advanced features like user authentication, access control, or a web interface, You'll want to explore other self-hosted solutions like
Mm.
GitLab Community Edition, Gitea, or GOGS.
Those sound like they offer more bells and whistles, like having a full-fledged concert hall with all the amenities.
Right, with self-hosting, you have the freedom to customize your Git environment to your heart's content, just like designing your dream concert hall.
This has been an incredible journey through the world of Git. We've learned about its history, its core concepts, advanced techniques, and even its impact on collaboration, security, and hosting. But beyond the technical aspects, Git has had a profound impact on the culture of software development and beyond.
Absolutely. It's fostered a more open, transparent, and collaborative way of working. Open source projects in particular have flourished under Git's influence, creating a global community of developers sharing their knowledge and passion.
It's like Git has broken down the walls between individual performers and created a grand orchestra where everyone can contribute their talents.
It's also changed the way companies approach software development, making them more agile, efficient, and responsive to change.
So it's not just about code, it's about a new way of thinking and working together.
Precisely. Git embodies the principles of transparency, iteration, and continuous improvement, which are valuable not just in software development, but in any field where collaboration and innovation are key.
You've learned a lot about Git on this deep dive, from the basic commands to advanced techniques, but the real journey begins when you start using Git in your own projects.
Remember, it doesn't have to be a complex software project. You can use Git to manage anything that changes over time. Writing a novel, composing music, designing a website, you name it.
Exactly. Git can be your trusted companion, helping you track your progress, experiment freely, and collaborate with others. So go forth, embrace the power of Git, and see what incredible things you can create.
Happy Gitting.
And that's a wrap on this deep dive into Git. Be sure to check out the show notes for links to the Pro Git book and other resources to help you continue your Git adventure. Until next time, keep learning, keep exploring, and keep those commits coming.